Hello, in this video we are gonna go over the solution of the problem 322 coin change, and in this problem we are given this description. Let's read that. It says you are given an integer array coins representing the coins of different denominations and an integer amount representing the total amount of money, and return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, returns -1. You may assume that you have an infinite number of each kind of coin. Okay? So for example 1, we can see the coins array is this one. So it means that I have a value 2 coin, I have a coin with value 5, and we have an infinite number of each type of coins. And the amount is 11. And the output should be 3. Because we can have, for example, 2 coins of 5 and 1 coin with value 1. We can have only 3 coins that the summation is 11. For example, we could have another combinations, for example, 11 coins 1, but that is not going to be the minimum number. So we are looking for the minimum number. The other example, for example, here is coins 2. So it means that we have only coins 2 and the amount is 3, so it is impossible to reach that. So we are returning -1. And the last example, we can have a coin with value 1 and the desired amount is 0. So we are going to return 0 for that. Okay, we are going to solve this problem using dynamic programming, and we are going to use the bottom-up approach. And let's start coming up with the formula we need to do that. So for the example we just showed, our coins were 1, 2, and 5. Okay, and the amount, let's assume that is 6. We could say for the amount 0, this is gonna be show the amount's value here. We are gonna return 0. Why? Because for the amount 0, we are not gonna return any coins. Okay, for the amount 1, so I can select a coin 1, this coin, the first coin, let's say call it C1, C2, C3. So I can select the C1. So when I select C1, I'm using 1 coin. Okay, I put 1 here. If I do that, I can say what is the remaining amount, because the coin was 1. So now I can put the DP of 0 here, because the remaining amount is 0. I use the coin 1 with the value 1. Can I use any other coin more than C1? We cannot, because those coins are 2 or 5. They are greater than the amount we are looking for. So we can't use that. So we go for the next amount. We say DP2 equals, if I use C1, I'm using 1 coin. And what is the remaining amount for me? So the amount is initially was 2. Now I use C1. So here I have 1. I can also do this one for 2. I'm using C2. I'm using only 1 coin of C2. And the remaining amount, because I'm now using a coin with value 2, C2 is 2. So the remaining amount is 0. So let's go forward with this approach. So here we know DP0 is 0. So we can put it as 1. For this one, DP1, we just calculated as 1. So it's going to be 2. For DP0, we calculated already, that is 0. So this one is 1. So now I have 2 values for DP2. So our intention is to find the minimum of that, because we are going to return the minimum amount of coins. So we say this is 1. Okay? And we can continue this process and calculate the DP of 6. We can come up with a formula to do this. Let's try to do that. So it seems that we are doing something like this. It seems that we are saying dp of amount A equals 1 plus dp of amount A minus the coin value we used. For example, if the coin value here is C1, this one is C1. If it is C2, this one is C2, and so on. Okay. And we could have different C, and we want to calculate its minimum, so we can modify this and create that minimum. So for doing that, let me shift this to the right, and we say this is a minimum of dpa and this one. Okay, and we are gonna have a for loop here for C1, C2, and C3. Okay, and we calculate the minimum. Also, we could have, because this is the amount A that we have here, we start from 0. We're gonna start from 0 and go all the way to the desired amount. So we could say, for example, for A in range of we already calculate the A0, so we can start from range 1. Okay, so something like that. Okay, we have the formula. The last thing that we should also consider is that, for example, for amount 1, we saw that we only used one coin because we can't use C2 or C3. The values are too high for this amount. Or for amount 2, we only used C1 and C2. We never used C3 because the amount was greater than the desired target. So when we have this for loop, we also need to make sure that the amount A minus C is greater equals than 0. So we can just have if statement here and say if A minus C is greater equals to 0. In that case, we just do this, otherwise we continue. Okay, we know that dp0 is 0, so let's put the value for that. Okay, now we are gonna loop over the amounts, and we say for A in range of 1 to the amount plus 1, and then we go over the coins. We say for C in, okay, and then we have our if statement. We say if A minus C is greater equals 0, means that we have a coin that is less than amount, so we can use that coin. We are gonna use our formula. We say dpa equals the minimum between dpa and 1 plus dpa minus c. Okay, also, as we are using this minimum, we need that initial value for dpas, and we can create very large numbers for them. So we can say dp is a list that has very big numbers. For example, it could have infinity, and the size of that is gonna be amount plus 1. The reason is that we also have dp0. For example, if amount is 6, I need dp0, dp1, dp2, all the way to dp6. Okay, and we have the initial value for dp. We should be able to calculate and update this formula, and at the end we are gonna check to see if dp6 or dp amount is calculated or not. Say return dp amount if dp amount is not the default value, so it means it's not equal to that infinity we defined. Okay, if it is not calculated and remain as the default, we are just gonna return -1. Okay, let's run it, and you can see we get the output 2, because for creating 6 we can have a combination of for example, coin 1 and coin 5, and with only 2 coins, we should be able to get the amount 6. Okay, now let's talk about time and space complexities. For the time complexity, we have this for loop here that we go over the amounts. For example, here amount is 6, so we are gonna go over from 1, 2, 3, 4 all the way to 6. So for this one, the time complexity, let's call it amount. So we go over all of them, and also we are gonna go over the coins and check all of these values in this list. And because of that, that is gonna be the order of the length of the coins. So you could say order of the length of the coins. Okay. And as the result, our time complexity is the multiplication of these two values. So it's gonna be order of amount times the length of coins. Okay. For the space complexity, we saw that we created this DP to record the values. So because of that, and the length of that is gonna be the length of the amount. So we say that is order of amount. Okay. Okay, this is the solution of the problem 322, and thank you so much again for watching this video.